Hello everybody. In this video we will discuss a couple of problems involving Henderson-Hasselbalch equations. Alright, so let's begin. So this question is asking what is the ratio of conjugate base, which is our A minus, to our acid at pH 7 if the pKa of the reaction is 3.0. So this is our reaction. So you have a carboxylic acid group. Again, this pKa may not be right. I'm just giving you fake numbers here. So what would happen for this particular reactions if at pH 7? So remember, pH is something you can control, pH of your solutions. So as per our Henderson-Hasselbalch equations, so let me use a different color. So based on our Henderson-Hasselbalch equations, so what was it? Henderson-Hasselbalch equations. It's pH equals to pKa plus log of conjugate base A minus concentrations divided by HA. So in our questions, we were asked to find this A minus HA. Sorry, I forgot to add the square bracket. So in our questions, we were asked to find the A minus by HA. All right, so this is what we are asked to find. Let's solve this problem. So we have our pH. What was the pH? pH is 7. And what was the pKa? pKa is, where is it? Here. So pKa is 3.0. So now we just plug in and play. So here is 7, 3.0, log of A minus by HA. So which means 7 minus 3 is equals to log of A minus by HA. So this means 7 minus 3 equals to 4, which is gonna be log of A minus by HA. All right, so at this point, you notice we have solved up to the final one. So now we have to just get rid of our log. So since it's a base of 10, so basically what we can do is we can add an anti-log of 4, and then that will cancel out the log. So this is gonna be basically 10 to the power 4 is gonna be A minus by HA. So now the reason I gave you this problem is to find out which one is more. So you notice if the number here is greater than 1, that means our numerator is going to be more than denominator, right? So obviously 10 to the power 4 is greater than 1. So if you know, if it is greater than 1, then A minus concentrations, it's going to be more than HA. If it is equals to 1, so the equilibrium constant basically, it's gonna be A minus concentrations is gonna be equals to HA. And if it is less than 1, then obviously A minus concentration conjugate base should be less than HA. Okay, so in this case, obviously, well, we find out the answers, but I want you to focus on the idea that what exactly happened here. So we have more of this and less of this at pH 7. So let's summarize our data. So let's draw a pH lines. And so pKa is, for this particular problem, is 3.0. And our reference pH, so this is our reference pH. And at reference pH, which is 7, so at reference pH, we have more of our COO minus. So we got this more. So you noticed when your reference pH, the pH at which we are discussing, is higher than pKa, you're gonna get a lot of conjugate base. Okay, so if you try to solve this problem, any pH below 3.0, any pH below the pKa value 3.0, you're gonna get more of RCOOH. So you can do it yourself, solve this puzzle. Find the ratio of A minus by HA at pH 1 for the same problem. Okay, the answer would be, you can test yourself, the answer would be 0 to, not 0, it will be 1 to 100. So it's gonna be A minus is gonna be 1, HA is gonna be 100. So you got more of HA. Okay, so let's do another problem here. So what is the ratio of conjugate base to acid for this particular example? So we apply the same principle, pH equals to pKa. The reaction is not important, but I will explain in the next video why I have used this particular example. pH plus pKa of log of A minus by HA. Okay, since I will use conjugate base here because there was no negative ions, but it doesn't really matter. Conjugate base divided by acid. So again, we were asked to find out the ratio of these, the ratio of this, and we were given the pKa, which is 8.0, and we were given the pH, which is this. So it's gonna be 7 equals to 8 plus log of conjugate base divided by acid, and 7 minus 8 is gonna be log of conjugate base by acid. So it's gonna be -1 log of conjugate base by acid. So it's gonna be 10 to the power -1. And what is our conjugate base, by the way, here? Our conjugate base is RNH2. So concentrations of amine RNH2 divided by concentration of RNH3 plus, which is our acid. So it's 10 to the power -1. So 10 to the power -1 is basically, what does it mean? It means 1 divided by 10, right? So which one do we have more in this case? So you see, this is more, and this is less. So same thing, if we draw a line, pH line, and the pKa, if we show them here, is 8. Any pH lower than pKa, which is our reference pH for this particular problem, is, so the question's pH was 7, and when the pH is 7, it is smaller than, so you're gonna get more of acid. And if I would have asked what would happen at pH 9, then you would get more of conjugate base. Okay, so anything higher than this, you're gonna get more of conjugate base. Anything below than pKa, you're gonna get more of acid. So what is the definition of pKa based on our previous video? So if your pH is exactly as same as pKa. So this is we call the sweet spot, right? So let me move this one out. So at this point, if your pH is exactly as 8, then your concentration of acid is gonna be equals to concentration of conjugate base. Any pH higher than this, any pH higher than 8, you're gonna get more of this. Any pH lower than this, you're gonna get more of acid. So that's mathematically we prove that when your pH is higher than higher than your pKa values, you're gonna get more of conjugate base. All right, let's stop this video here.